Lasalians! Welcome back to Liceo Math Club YouTube channel. Before we head into our topic, don't forget to check out our social media pages to be updated with more of our math lessons. Today, we will be discussing to you a new topic, propositions and truth tables. Before we begin, let's find out first the objectives that needs to be accomplished.
First, to know and define propositions and truth tables. To differentiate categorical proposition from hypothetical proposition, and lastly, to be able to translate statements into symbols and symbols into statements. To begin with, let's define what is a proposition. Proposition is a declarative statement that affirms or denies a certain situation or subject, but not both, which may be true or false. The truth value of a proposition is true, denoted as capital letter T if it is a true statement, and false, denoted as capital letter F if it is a false statement. Remember, a proposition has only two possible values. It is either true or false, and it cannot be both. Here are some examples of identifying a proposition. Beginning with the left side of our screen, the water is blue, 2 plus 2 is equals to 5, weight is equal to mass. The first and the last statements are propositions which are declarative in form and are valid or true, while the second statement is also a proposition but invalid or false. It is because, as we can see, 2 plus 2 is obviously not equal to 5, but rather 4. Next, let us read and analyze the examples from the Not a Proposition column. For the first example, x is less than y. Please open the door. Are you okay? The first example is not a proposition since the statement cannot be clearly assigned a logical value of either true or false. We cannot prove from the statement x is less than y if it is true or false since there are no true values. The second and last statements are considered not a proposition because they don't affirm or deny and does not contain a truth value. And the third one does not encompass the condition of a proposition, which it should be in a declarative form. It is important to remember that not all statements are propositions, since a proposition must have a logical value of either true or false. Moving on. A proposition have two classifications, namely categorical and hypothetical proposition. Let's find out what they mean and their differences. For the first classification, it is categorical proposition. It is a statement that affirms or denies something absolutely, directly, or without any conditions. For example, all professional teachers pass the board exam. The statement directly explains and affirms that the teachers pass the exams without any conditions written in the statement, which is also the same as the rest of the example. For the statement number 2, it states that some students are attending the workshop today. Manila is one of the populated areas in the Philippines. All human beings are mortal. All statement encompasses the conditions of a categorical proposition that affirms something directly or without any condition. Let's move on to the second classification of proposition. Hypothetical proposition. It is a statement that affirms or denies something with condition. It takes the forms of if P, then Q. For example, if a man is far-sighted, then he needs eyeglasses. If mathematics is important, then students should study it. If today is Saturday, then tomorrow is Sunday. If we had not eaten, then we would be hungry. All four statements, the first part, if, is labeled as the antecedent, and the second part, then, is labeled the consequent. The following statement does not have unconditional affirmation or denial, but expresses a relation of dependence, such as an opposition or a likeness between two clauses. In conclusion, categorical proposition is a statement which affirms and denies without any conditions, while hypothetical proposition is in form of if P, then Q with a condition.
Now that you know the difference between a categorical and a hypothetical proposition, let's test your knowledge with a short assessment. You will only identify the statement if it is categorical or hypothetical. I will give you 30 seconds to answer. Time's up. Congratulations if you got all your answers correct. If not, just rewatch the video and take the assessment again. Now let's move on to the logical connectives. You would wonder, what is a logical connective? Well, logical connectives are symbols which is used to connect two or more propositional or predicate logics in such a manner that resultant logic depends only on the input logics and the meaning of the connective used. If that doesn't make sense, I will show you what are the 5 logical connectives. What is shown on the screen are the connectives in symbols and its corresponding meaning. On the upper left corner of the screen, you can see a wavy line or a rotated L, which means not or it is not the case that. Next is an inverted V, which means and, also, or but moreover. Next is V, which means either or unless. Next is an arrow pointing to the right, which means if then, and the last logical connective symbol, an arrow pointing both sides, means if and only if. Moving on, let's now learn how to use these connectives by translating statements into symbols and symbols into statements. Let's do the translating the statements into symbols first. Given that A, he is rich, and B, he is happy. As you can see, there are 3 statements below and we will together translate this into symbols. The first statement is he is not rich. With this, we can see that the logical connective used is not, and the rest of the statement corresponds to condition A, then we should answer using the symbol of not and the condition A. Put it all together, it will look like this. Next statement is, if he is rich, then he is happy. Following the steps we did from the first statement, the symbols would be like this. The last statement is, he is not happy and he is not rich. The end connective is used so the inverted V symbol will be used, and considering that both conditions have a connective not, we should enclose both condition A and B together with the symbol of and, which is the inverted V with the symbol of not. Put it all together and it will look like this. Now, let's do the translating the symbols into statements with the given conditions that P, the student studied, and Q, the student failed. With 3 symbols below, let's go on translating them into statements. The first statement would be the student did not fail because of the symbol of the condition Q, which is the student failed, and the logical connective not. Put it all together, the statement would be the student did not fail. Now, next is this symbol. Put it all together, given that not and connective symbols are used, the statement would be the student did not study and the student failed. Next is this symbol. Considering that the if then connective and the not connective is between the conditions P and Q, then the statement would be if the student studied, then the student will not fail. If you're still confused with translating statements into symbols and symbols into statements, just rewatch the video and practice. This ends our tutorial on propositions and truth tables. We hope that we are able to help. For more math tutorials, please like, subscribe, and share, and please leave a comment down below. Thank you for watching and have a nice day.